Today's class exercise is exercise 7, which is data conversion. So, until this class, we have been learning how to display, how to edit, and analyze different types of spatial data in QGIS. But today, we are going to learn something that almost every GIS professional, researcher, and industry expert uses regularly, that is data conversion. Right? So, here, let me begin with a simple question. Imagine that a government agency provides you with a land use map as an image, but your task is to calculate the area occupied by agriculture, forest, and water bodies separately. Right? So, can you directly calculate those areas from the image? Probably not. So now imagine another situation. You have a district boundary which is stored as a polygon shaped file, but your next analysis involves satellite image processing, machine learning classification, or suitability modeling. So where everything is performed on raster data. Again, you cannot directly proceed because one of your data is in vector format, which is not matching with the subsequent data. So, what is the solution? The answer is data conversion. So, today's exercise is not simply about clicking few buttons in QGIS, it's about learning how to make different types of spatial data communicate with each other. Right? So in GIS, we mainly work with two data models. One is raster model and another one is vector model, right? And what is raster model? Yes, it's where the entire earth is represented as grid of pixels. So every pixel stores a value, making raster ideal for satellite imagery, elevation models, temperature maps, rainfall distribution, vegetation indices, and many other environmental data sets. So vector data is where we represent the real world objects as points, lines, and polygons. So we know very well that roads and rivers will generally be a polyline feature, and buildings, district boundaries, villages, so and other land parcels are some of the examples for polygon features. Right? And some of the locations, of course, the well locations, temple locations will be marked as points. So each data model has its own strengths here. Right. So, what is the advantage of raster data? Raster data is excellent for continuous phenomena. And what is the advantage of vector data? Vector is excellent for representing precise geographical features and performing measurements. But in real world GIS projects, we rarely receive the data in the format we actually need. So that's why GIS professionals constantly convert the data from raster to vector and from vector to raster. So depending on the analysis they are performing. Today we will perform both the conversions, right? So first we will convert one raster image into vector polygon using polygonize tool. And second, we will convert one raster vector data, that is Tamil Nadu boundary shape file, into raster format using rasterize tool. So this prepares the data for raster based operations such as after converting that vector file into raster, you can use that for various other raster analysis like overlay analysis, suitability modeling, or terrain analysis, and many other remote sensing applications. So, as you perform this exercise, don't think of it as merely converting one file format into another. Think of it like translating between two languages. So, like how your English and Tamil express same idea differently, raster and vector represent the same geographic information in different ways, right? So, data conversion is like a translator that allows these two languages to work together. By the end of this exercise, you will understand not only how to convert the raster and vector data in QGIS, but more importantly, when and why each conversion is required in real GIS projects. So let's open QGIS and see how this transformation actually happens, right?